So now we move forward in the chapter matrices. So in the earlier video you have seen the addition of matrix, subtraction of matrix, and if you want to multiply a single number to the matrix, then how you do that, and the exercise 9a and 9b from Concise. Now we see the most important part of matrix and the most confusing part of matrix, that is multiplication of matrix. Luckily so that we do not have any division of matrix. Matrix ka division is not possible. We cannot do any division of matrix. So that's why multiplication becomes a very important part of matrix. So what we are going to see now is how to do the multiplication of matrix. Now the first and foremost thing is about when is it possible to do the multiplication of matrix and when it is not possible to do the multiplication of matrix. So let's see, the first thing is, suppose there is this matrix 1 which is A and matrix other one which is B. The matrix 1 is of the order 2 by 1 and this is by 2 by 1. We can see over here that both of them are of the same kind. That means this one is over here 2 by 1 means 2 rows, that is 1, 2 like this, and another one multiplied by like this 2, 3. Suppose this is the matrix which I need to multiply. I can see over here that this is the number of rows, this is the number of columns, this is the number of rows and this is the number of columns. So I'll take this as RA, CA, RB, CB. Because RA, rows of A, C, columns of A, rows of B, columns of B. The first and foremost thing is to check whether multiplication is possible or not, and that is to find whether CA is equal to RB or not. This is the first thing. If it is yes, only then multiplication is possible. Multiplication is possible only if CA is equals to RB. That is, if this is equals to this, only then it is possible. Here it is different, hence this multiplication is not possible. Understood? So if the number, if the number of rows in the first matrix is not equal to number of columns in the first matrix, is not equal to number of rows in the second matrix, then the multiplication of the two matrix is not possible. So that's the first and foremost rule which you need to check whether the multiplication is possible or not possible. Okay, so first check is to see whether column A and row B are equal or not. So that was the first thing. Now let's take another example over here. So in case if it is a 2 by 3 matrix and this is a 3 by 2 matrix, then it is possible. If it is 1 by 2 matrix and this is 2 by 1 matrix, because these are equal, therefore it's possible. If it is a 3 by 2 matrix and this is a 3 by 2 matrix, because this is 2 and this is 3, so not possible. This is 2 by 2 matrix and this is 2 by 2 matrix, because both are same, that's why it is possible. So understood when the multiplication is possible and when the multiplication is not possible. If this over here is equal to this over here, then it is, if this is equal, so CA equal to RB or C1 equal to R2. If I take this is the first matrix and there is the second matrix, so agar first matrix के number of columns is equals to second matrix के number of rows, only then it is possible to multiply the matrix. You cannot multiply the matrix if this is not coming out to be true. Got it? So the first thing is, when is the matrix multiplication possible? when the number of number of columns in the first matrix is equal to the number of rows in the second matrix. We go to the next part now, that is, what if it is possible, then what is the next step? So let's consider a matrix which is a 3 by 1 matrix, and this is a 1 by 3 matrix. So I can see that this is equal to this. So first thing, as multiplication is possible. The next thing is that what will be the resultant matrix be? Okay, what will be the resultant? I'll make it slightly simple. So this is 2 by 2, 2 by 1 and 1 by 2. So in case the multiplication is possible, then the resultant, so this is, you have to check whether it is true or not. So when you check, the second thing is, what is the resultant? Resultant matrix. What will be the resultant matrix will be? The resultant matrix will be 2 by 2. So that means the resultant matrix will be RA into CB. The number of rows of the first matrix is the number of rows of the resultant. Number of columns of the second matrix is the number of columns of the resultant. Accordingly, you can see that if it is a 2 by 1 into 1 by 2 matrix, the resultant will be a 2 by 2 matrix. I will give you an example of this thing, that if there is a matrix 1 which is 2, that is 1, 2, this is 2 by 1, and another one which is 1 by 2, so it is 1, 2 like this, then if you multiply this 2, the answer will be like A, B, C, D. Okay, answer to this will be in a form like this. How do we get this? What is the value of ABC? We'll come next time. But right now you need to understand what will be the resultant matrix look like. Okay. So you can see that it will be such that is k number of rows or is k number of columns will be this resultant. So that means number of rows of first and number of columns of second will be the resultant. Let's take one or two examples of this thing. We have over here as, if it is a 3 by 2 matrix by a 2 by 3 matrix, the result will be 3 by 3. If it is a 2 by 2 matrix multiplied by 2 by 2 matrix, the resultant will be 2 by 2. If it is a 1 by 3 matrix multiplied by 3 by 1 matrix, the result will be 1 by 1. Understood? So in this way, you can find out what will be the resultant of the given multiplication, because multiplication it is not going to happen that 1 by 2 matrix into 1 by 2 matrix give me 1 by 2 matrix, because 1 by 2 matrix into 1 by 2 matrix is not possible. I gave you that example, 1 by 2 and 1 by 2. यहाँ पे 2 है, यहाँ पे 1 है, तो ये possible नहीं है. So there is not possible. 1 by 2 matrix into 1 by 2 matrix is not possible at all. So we cannot have a resultant over here as 1 by 2. So we'll find that if any number, if any matrix is given, you find out the order of the matrix, find out the order of the second matrix, see whether these two are same or not. If they are same, then the resultant will be like this. Understood? This is the first point. Now let's go for the actual thing, what is to be done if the multiplication is possible. So we'll take an example over here, a simple example. We start with a simple example now. So let's take a simple example as this is a 1 by, we'll take a 2 by 1 matrix by 1 by 2 matrix. So because this is equals to this, so therefore multiplication is possible. Resultant will be a 2 by 2 matrix. Okay, so let's take an example. This matrix over here is 1, 2, and over here it is 3, 4. So this is the matrix 1, 2 by 1, and this is a matrix 1 by 2. Now, pay attention. For multiplication, what I will do is I will see this number. That is the number of columns in my resultant. Here it is 2. So I will write the first matrix twice like this. 1, 2. 1, 2. Okay. Because I have got 2 over here, I will write the matrix twice. Now remember this thing, whatever method I am showing you right now is different from what is explained in the textbook or the one which may be explained in the by school. What I am showing you is an easier method, but when you write the whole thing, so whether you write it in my method or you write it in the school method, the resultant what you see over here as written part will be exactly the same. So don't worry about that. Don't worry about the method in which you are writing. Important thing is that the result is going to come same. What my method is slightly easier to understand rather than multiplying the rows and columns and rows. तो थोड़ा difficult हो जाता है कभी-कभी समझने के लिए. Okay, so here remember one thing, if the multiplication possible, you check the number of columns of the resultant. Depending upon the number of columns in the resultant, you are going to write the first matrix that many times. So here the first matrix is 1 2. I am going to write it 2 times. So 1 2 1 2. I wrote it 2 times. Now I will start with the next matrix, and this one, the first number I am writing over here both way, into 3 into 3. Over here into 4 into 4. Got it? So this is 1 into 3, 2 into 3. Why? Because the first number has to be written in the first line, second number in the second line. Okay? So this will give you the resultant answer as, this is 3 6 4 8. So the multiplication of this into this is this. Are we clear on this? Let's take one more example. I will take an example wherein I'll take something more now. Let's take a number which is a 2 by 2 matrix. So I have got a number over here is 1 2 3 4 multiplied by, over here is, let's take some number which is different than this. So it is 5 6 7 8. Okay, so you can see it's a 2 by 2 matrix. So 2 by 2, 2 by 2. So the resultant will be 2 by 2. So I have to check this particular number over here. This is 2, means I need to write the first matrix twice. How? 1 2 3 4. 1 2 3 4. You can see this is going to be my one part. This is going to be giving me the first element, second element, third element, fourth element. Now, how do we speak? I told you in the earlier video that how do I normally speak a particular matrix will be like this, right? We are going to follow this way. So we are going to take the first number 5 and multiply with the first one over here. So into 5 into 5. Here into 6 into 6. Here into 7 into 7. Here into 8 into 8. Got it? So the first number with the first thing over here, second number with the second thing over here, third number with the third thing over here, fourth number with the fourth thing over here. And I am going to put a plus sign to one matrix. See, this was one matrix. 1 2 3 4 1 matrix. So I have a plus sign over here and plus sign over here. Plus sign over here, plus sign over here. Close this bracket. You get over here 5 plus 18. So it is 5 plus 18. This is 10 plus 24. This is 7 plus 24. And 14 plus 32. Hence, the resultant answer is going to be 23, 34, 31 and 46. This is the answer for this multiplied by this. Are we clear with this? Did you understand this thing properly? That for multiplication, you are going to put this particular matrix twice. You are going to write it twice. 1, 2, 3, 4. 1, 2, 3, 4. Got it? And then you are going to put the first row over, first column over here will be with multiplied by the first number. Second column with the second number. Third column with the third number. Fourth column with the fourth number. Am I clear? Okay, let's take a slightly difficult example. We'll take an example which may not be in your syllabus, that is the 2 into 3 kind of a thing. So we have over here as one thing which is 2 by 3. So it is 1, 2, 3, 4, 5, 6. And over here multiplied by like this as 1. Sorry, I'll make it something different. So let it be, okay, we'll try it this way only. So it will be 3, 2, 1, 4, 6, 5. Now, let's check whether multiplication is possible or not. This is a 2 by 3 matrix and this is a 3 by 2 matrix. Okay, 3 rows, 2 columns, 3 by 2, 2 rows, 3 columns. Now, because this is equals to this, so multiplication is possible. Resultant will be 2 by 2. So this is the resultant. Okay, I see this number. This number is 2. Means the first matrix I am going to write it twice. So let's write it first number twice. So it is 1, 4, 2, 5, 3, 6. 1, 4, 2, 5, 3, 6. Now let's start with this one. The first number is 3. So the first column will be multiplied by 3. So into 3, into 3. There will be a plus sign between because this is the whole one matrix. Now 2 into 2 into 2. So that was this number done. Now this number is done. Now we come to the next one. There is a plus sign here and into 1 into 1. So that gives me this number. Now we come this one. So it is into 4 into 4. Now plus plus. Now this is done. Now the 6. So into 6 into 6. So this is done. Now plus plus into 5 into 5. This was my one matrix. So this I added together. This is another matrix added together. So resultant over here 3 plus 4 7, 7 plus 3 10. 12 plus 10 22, 22 plus 6 28. 4 plus 12 is 16, 16 plus 15 is 31. So 31. 16 plus 30, so 46, 46 plus 30, 76. So this is the result of this multiplied by this. Did you understand this? This was very, very, very important for you to understand. Now, whenever you see the method what the textbook has given or what your school will try to give you, you will find that whatever you write over here is going to be the same by that method also and this method also. I am not teaching you that method because I don't want to confuse you. I don't want you to know that ये row के साथ ये column multiply करो और ये row के साथ ये column multiply करो. No, that row column business, let us not do it. Okay, let us understand this way. If you are comfortable with that method, if you are comfortable with them, I have no issues, it is absolutely fine. Whatever comfortable to you, you use that method. But this, I find it much more easier to understand, much more easier to apply. That's the reason I normally follow this method, wherein, irrespective of the number of rows or number of columns, I can easily make this thing possible. So this is how you are going to have this particular thing. So we can now start with the exercise, right? So we start with the exercise 9C. You see the 9C is quite a big one, and then 9D will be your homework. So we will go for first 9C. Okay. They ask us evaluate if possible. So the first 9C, first sum is given as 3 2 multiplied by 2 0. Okay, 3 2 2 0. What is the thing over here? This is nothing but 1 by 2 matrix. This is a 2 by 1 matrix. Okay, so therefore this and this are equal. Resultant will be 1 by 1 matrix. So here the number is 1, so I'll write it only once. So it is 3 2. Now into 2 into 0, because this was one matrix, therefore a plus sign over here. So the resultant is nothing but 6 plus 0 is equals to 6. So this is the result of multiplying this. You can see this is 1 by 1 matrix, 1 row, 1 column. So just a single number 6. So that's why this is the answer. Understood? We see the next one. Sum number 3. Sum number 3 is given as 6, 3, 4 minus 1, and the next one is minus 1, 3. Okay, this is a 2 by 2 matrix and this is a 2 by 1 matrix. So it is equal. So yes, it is possible. The resultant will be 2 by 1 matrix. So that's why I'll write the first one only once. So I'll be writing over here as 6, 3, 4, minus 1. Now the first number into minus 1 into minus 1 plus plus into 3 into 3. Why this plus? Because this was one matrix. So the resultant will be given as minus 6 plus 12 minus 3 minus 3. So that gives me the answer as 6 minus 6. Understood? This is how you do the multiplication of matrix. Is it clear? Okay, we'll just cross check the answers so that there is no issue later on. So that's exercise 9, 6 and 6 minus 6. Yeah, perfectly right. We go to the next sum, that is sum number 2. Sum number 2, they are given you two matrix and they ask you to find out the values of 6 different things. We'll be doing any 3 of them. So we are in the first one as A is equals to 0, 5, 2, minus 2 and B is equals to 1, 3, minus 1, 2, and there is one I. Now I, we know I, the value they will not give you. I is nothing but the identity matrix. In the first lecture of matrix I had given you the details that I is nothing but unit matrix, which is 1, 0, 0, 1. They are given you that I over here is a unit matrix of the order 2 by 2. What do you mean by order 2 by 2? Like this. A unit matrix of order 2 by 2 is 1, 0, 0, 1. Okay. Now let's see what are the questions given to you. You are given the values of, find the value of AB, AI and A square. That is based on my sums. The alternate sums are your homework. So first thing is AB. Now remember one very important thing. In case of multiplication, A into B is not equal to B into A. So what I'll do is that instead of doing the first and the third sum, I'm doing the first and the second sum to let you know that how A and B are, AB and BA are not the same. Okay. So we'll just do the first and the second sum instead of the third sum. Okay. So AB. What is AB? AB will be 0, 5, 2 minus 2 into 1, 3 minus 1, 2. 2 by 2, 2 by 2, resultant will be 2 by 2. Hence, how many times you write this? Twice. So, let's see this. 0, 5, 2 minus 2. 0, 5, 2 minus 2. Now, we start with this. Into 1, into 1. Into 3, into 3. Into minus 1, into minus 1. Into 2, into 2. Got it? Into 1 over here, into 3 over here, into minus 1 over here, into 2 over here. This is one matrix, hence plus sign. This is one matrix, hence plus sign. Okay. So this, I need to put a bracket so that there is no confusion. Resultant over here will be 0 1s are 0, 0 plus 6, 5 minus 6. This is 0 plus 4. Minus 5 minus 4. So that's why the answer will be 6 minus 1, 4 minus 9. Okay, that's the first answer. Let's find out the value of the next thing, and that is, let us find out what is BA. So if AB was equal to BA, then the answer would have come same, but let's see what we are getting the answer now. 1, 3 minus 1, 2, and the next one is 0, 5, 2 minus 2. So here, this is the first matrix, and the resultant will be 2 by 2. So this one I will write twice. So it will be this way: 1, 3, minus 1, 2, 1, 3, minus 1, 2. Into 0, into 0, into 5, plus signs here. Into 2, into 2, plus signs here. Into minus 2, into minus 2. This is my setup. So here answer will be 0 minus 5, 0 plus 10, 2 minus 2, 2 plus 2, 6 minus 4. So the answer is minus 5, 10, 4, 2. You can see, therefore you can see that AB was not equal to BA. This is very, very, very important. AB was 6 minus 1, 4 minus 9. BA completely different. Not even a single thing is common. So here, yeah, okay, 4 is there, but that's just a coincidence. But in minus 5, 10, 4 and 2, you can see that the values of A into B will not be equal to the value of B into A. So we'll just check that answer. That was the 6 minus 1, 4 minus 9 and 5 minus 5, 10, 4 and 2. Okay. We now see how to do the fifth part of that thing, that is A square. So I'll put that over here as A square. So what is A square? A square is nothing but 0, 5, 2 minus 2 into 0, 5, 2 minus 2. Simple, right? A into A is A square. That's it. So accordingly, what will happen? I am going to write this one twice. 0, 5, 2 minus 2. 0, 5, 2 minus 2. Now, into 0, into 0, into 5, into 5, into 2, into 2, into minus 2, into minus 2. Plus signs here, plus signs here. Resultant over here is 0 plus 10, 0 minus 10, 0 minus 4, 10 plus 4. So answer is 10 minus 10 minus 4, 14. This is nothing but A square ka value. Understood? So A square will be A into A. That's going to be A square. Answer is 10 minus 10 minus 4, 14. Understood completely? Now let's move on to question number 3. If you follow a proper system for multiplication in matrix, then matrix multiplication becomes very easy. Otherwise, you always keep on getting confused about this thing. So, be very specific about this thing. Now, let's see the next one. That is the third one. It is given that A is equals to 3, 0, x 1 and B is equals to 9, 0, 16 minus y. You need to find the value of x and y when it is given that find x and y when A square is equals to B. Then again that A square is equal to B. So first of all, I'll find out the value of A square. So it is this way: A square is equals to 3, 0, x 1 into 3, 0, x 1. Accordingly, what we have over here will be multiplying this thing, we'll write this twice. 3, 0, x 1, 3, 0, x 1. Now, into 3, into 3, into 0, into 0, into x, into x, into 1, into 1. Plus, 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 plus. Got it? Now, so this is nothing but 9, only 9 plus 0, right? This is 0 plus 0, so 0. Over here is 3x, so this one is 3x plus x is 4, 3 into x is 3x, into x is plus x is 4x, so it is 4x. Here it is 0 into 1, so it is 1. So that's the value of A square Now it's given that so this is a square. It is given that a square is equals to b. That means it is 9, 0, 4x1 is equals to 0, 0, 9, 16 minus y. Okay, I think there is a mistake over here because why is it 0? One second. Yeah, I have the mistake over here. This is 9, right? So this is 9. So 9 is equal to 9, 0 is equal to 0. So accordingly, what will happen? You can see 4x will be equal to 6. So 4x is equal to 16. So x will be equal to 4. Next is 1 is equal to minus y. So y is equal to minus 1. So the answer is x is equal to 4, y is equal to minus 1. Understood? This is how you do the third sum. So that was sum number 3. Okay. I'll stop for this video. We'll continue in the next video.